Okay, a bit of a longer lesson. This is example 4 from 5.1. And what we're going to be examining here is doing two stretches. We're going to have a vertical stretch by 3 and a reflection across the x-axis, and a horizontal stretch by 1/2 because the b value is 2. And I think the best way of doing that is to graph it. Importantly, that you have one cycle space on your sheet. This is going to graph 2 cycles. We can see that 12 over here. Just again, writing that in, I wrote 2 pi in already. 12 would be 4 pi. I mean, approximately 12. It's a little bit past 12 for sure. So looking at the graph of y equals cos x, I'm just going to draw a nice big line right here because this is really all you have space for on your sheet, which is fine. That's definitely enough. That's one cycle. And we can see that the standard cos shape, right, emerging, that we have 0, 1, and this is pi over 2, 0, pi, -1, 3 pi over 2, 0, and then finally 2 pi, 1. What's going to happen here is that when we apply y equals cos 2x, again, important to identify exactly what's happening there. Y equals cos 2x is a horizontal stretch by 1 over 2. It's 1 over the b value. And what that does is it compresses our graph. Instead of one rotation along the blue line, we are getting 2 rotations along that red line. Now, I like doing this kind of all together, but I would never split y equals 3 cos 2x and y equals -3 cos 2x, because what I'm going to do, and it's very important that I am now stretching cos 2x. So to go from y equals cos 2x to y equals -3 cos 2x, I'm going to write this as a mapping. And what we are doing in this case is we are taking any point on y equals cos 2x. So that'll be the graph in red. And we are going to change that into x comma -3 times y. And again, that's because this is a vertical stretch by 3 and a reflection over our x-axis. All right, I'm just going to have to kind of step back and forth here. So we'll look at y equals cos 2x, and preferably you would do this in different colors so you can see this change. And when I apply that y equals -3 cos 2x, we see some pretty important things happening here. This coordinate, 0, 1, has become 0, -3. And we can see that in our mapping that we're merely taking the coordinate and multiplying y by -3. That's my vertical stretch by 3 and the reflection. All right, make sure you pause that. Let me just do one thing here quick. I'll put that final graph on. I know it's kind of nice to see it at the end. And then keep in mind that you only have to graph up to that black kind of partially erased line now. All right, the last part of this asks for a few kind of important characteristics about the graph. I'm going to reveal them here, and then we're going to talk through them one by one. So again, you can pause it. Make sure you write this down. Amplitude. You need to make this as simple as amplitude is equal to the absolute value of A. In this case, that's the absolute value of -3, which is 3. Period. And these are formulas or maybe equations that you really should remember or memorize. Period is going to be 2 pi over the absolute value of b. In this case, that's 2 pi divided by 2, which is just pi. Now, for maximum values and minimum values, because we haven't applied any kind of translation, we are going a units up from the x-axis, which gives me +3, and a units down from the x-axis, which gives me -3. The y-intercept is that first quadrant when x is equal to 0. I think it is important that if you're ever asked to calculate the y-intercept, it is usually as simple as putting, messed up the equation there, 0 in for x. And if I do that, I get that y is equal to -3 times the cos of 2 times 0, or y equals -3 times the cos of 0. The cos of 0 is +1, so I get that y is equal to -3 times 1. That should be a +1, sorry about that. So I get that y is equal to -3. And that is our y-intercept. Now, the x-intercepts are generated by looking at the graph. They show a nice condensed general formula for them right here. We will work on developing that skill. We've done a little bit about it in chapter 4. We will do more in chapter 5 as well. The domain of this function is all real numbers. There's no invalid inputs into cos. And then finally, the range is from negative, the absolute value of a, to less than or equal to the absolute value of a. I would highly recommend that if you've done the maximum and the minimum values, you use that info to talk about your range. That's really what the importance of talking about max and min are, because your function always exists between the minimum and the maximum value of its y. All right, I'm going to leave that assignment up. Make sure you are chipping away at these questions, and we will see you on Google Classroom for any questions you might have.